Well, hello there. I've got next to me a Black Oak LED light bar. Check out blackoakled.com for the highest quality builds for off-roading and outdoor use. Support this awesome family-owned business with a 20% discount, comms ENGR, at checkout. I'll see you on the trail.
What is going on, y'all? This is Comms Engineering, and in this video we're going to be custom making a movable light bar setup with some motors and a whole lot of 3D printing. Let's get into it. All right, so for this project we're going to be using a multitude of things. Typical breadboard, 2 MG995s, servo motors, an Arduino Nano. Originally for this project, I had chose the Arduino Uno board as my main component along with the 2 servo motors, but that quickly changed into the STM32 Nucleo board, which I had high hopes for, except that I just kept on running into problems with this. This one in particular had a broken reset button, so I couldn't even use it. I got 2, one for a backup. It's essentially the same MCU. So I got new ones. I don't know if you can see that red and green flash, that means it's debugging. One servo connected to power and ground over here, the other one over here. I'm gonna run this off of like 9 volts. I decided to return to the STM board later and solder some circuitry for the build. And it turned out like this. Obviously, I'm not looking to make it pretty. This is gonna be stuffed in some wire loom, but basically, first converter here, which is a 5-volt output, hooked up to a power supply, goes straight to the 3.31 for the actual MCU. That's right there. And then we've got some parallel connections to make sure the voltage reaches the DC motors. And I've got the multimeter out, of course, so I can measure everything correctly. Now I just need to hook up some external batteries for the button because I did forget to solder that connection over to the breadboard, but it's fine because we're not actually going to be using the breadboard since this is going to be separate when the full installation is complete. So none of that is part of the plan anymore. It is literally not working for some reason. I'm to the point where I have one servo motor hooked up to just test if it even moves. I've changed the counter period, the prescaler multiple different times, settings correct, 50 hertz, just straight up not working. So I'm gonna use a whole new board, which is the Arduino Nano board. I'm making kind of like a case or a brace for this servo motor. We've got some amount of threads going in, and I want to put clamps on the back, so here's how it looks. Realistically, this is going to be where the gear is, and the back is just where the wires come out of, and also the clamps. I'm not sure how I'm gonna do that yet, but stay tuned. Okay, so this is what I have for now. This is what we're gonna deal with. This gap is gonna go in there. These screw holes are gonna go hook up onto these. It's just the casing on the outside, so should be good. Pause it for a second to test it out. Looks like we are a bit short. I just forgot to scale. It's not going through, so I have another one going up in there. And that one has just 4.5 millimeters extension and should work. And she's a printing. After 1 hour, it should be done. So let's do something else. Laundry. Here it is. New one. Let's see. Goes like this. Pull these apart so that they can fit. Oh, yes, Lord. This is nice. This is gonna work out pretty good. So this is PLA, which is not great for if you actually want to attach multiple objects onto it, but it's great for prototypes like this. Other than that, PLA is straight junk. So I've got PETG, which is what I'm going to use, or actually considering TPU. We'll make a couple more and figure out how to do the clamping process. I then needed to design a casing for all my electronics under the roof rack. It kind of has a curvature to it. Now all I need to do is just make the indents and cover, which are going to be these 4 right here. They'll sit right on top of that casing. Looking good. And we're done. So all I need to do right now is kind of just sand it and put them together. I'm honestly kind of surprised that this worked because there's like so much extrusion coming out of the corners and the sides too. But hey, we got it to work. So we're just gonna sand this, wash them and sanded them. By the time there's going to be an adhesive on the back of a breadboard, and all you do is just kind of peel it off. Okay, perfect. So the way that this is going to be connected, the nano board, we've got 5-volt pin and then the ground pin to the HM10 module. Receiver pin is going to D4 and transmitter is going to D3. That's how the configuration is on this. It doesn't quite work with the actual transmitter and receiver pins on the Arduino. And then your 4 AA batteries will go to either power rail for the servo. You got ground, power. The signal wire for one of them goes to D8 and the other one goes to D9. And so basically you'll have a full circuit when you connect all of them. Okay, I just took the biggest clamp I got and clamped all of the 3D printed parts together. The epoxy should harden fully within like pretty much like 24 hours. We have a 20-inch LED bar right here. Woo-wee! Blue, eh? Shout out to Black Oak LED. Instructions for the installation guide and how to power this properly. Now, it is a 20-inch LED, 5 watts, single row. Nicely built. I like it. Well, it's gonna go on top of the roof rack first. Okay, so basically the way that it came in was like this. You'd pretty much have a screw coming out, and then you'd have a nut and 2 washers that was like fixated on it. You'd also get like this brace mount. I don't know, however way you want, really. I was just thinking of literally just leaving out this screw, like 3D printing an attachment to it. Yeah, just kind of like a leeway. Just made a quick design. This is gonna be the gap, and this is where the servo kind of gear is gonna go. All right, so here it is. We're focusing on this right now. There's a hole here for the 5.8mm screw. There's a thread inside of the gear for the servo, and all I really need to do is just drill a hole, attach it. I applied a little bit of epoxy too inside, and that's why you see all of the mess here. So there you go. Here it is being fixated on, and time to fit it. There you go. And all that needs to go here is the brace or the framing. So I've got an example code up for just the sweep for a servo motor, and now we've got it hooked up to a power supply, the Arduino, and now it looks like it is working fine. I originally used the free Bluetooth control module, but then ended up using this paid one, and it works pretty well with the ASCII value. And here's my just rough draft of the servo mount on the roof rack. It clips with the casing on top, so hopefully that should work. All right, took off one end, pushed it all the way through. Fits pretty tightly. Now bad boy's coming up. All right, so here I am testing out the full build. I've got everything mounted on. So I'm gonna connect the Arduino to the blacktop and just run some tests. Powered on. Okay. All right. So it should be on. The mounting did break on that side, but this one is epoxy, so it's really good. I'm gonna take this out and re-epoxy it. However, sometimes it may not fully function right off the bat, so I'm just gonna reconnect it. It is really just falling apart for the mounts. The servos are fine. It's just the mounting and the attachments to it. I do need some like really strong filament, but throughout this entire build, I think I'm gonna upgrade this next video. But let's just look at how bright this beast is. Shout out to Black Oak LED. This is an incredibly well-built LED bar. Like I mentioned, a 5-watt, single row, 20-inch LED. Incredibly powerful. Just amazing. I will definitely upgrade this movable build in the next video. I'll see you guys soon.